So hello everyone, welcome once again to my YouTube channel Delta Assam. Today in this video I am going to solve some important problems which may ask in your upcoming exam, that is ACES final exam 2024. So I have seen in some of the comments of some students that they have little bit doubts in differential equations. So I have adopted some questions which is related to differential equation first. Then after that I'm going to solve also some problems which is related to integration and differentiation as well. Okay, so let us start with some problems which is related to differential equation, and these questions asked in ACES final examination 2012. Okay, so question number 1, solve the differential equations. ठीक है सर, क्वेश्चन नंबर 1 और दिया से कि so in question number 1 we have given what, x square y x square into dy, so plus y square plus x y square into dx equal to 0. So let us solve this question, and this question can be solved so with the help of method of separation of variable. And for that we take some simplifications. Okay, so given equation is what, x square minus y x square into dy, so plus y square plus x into y square into dx equal to 0, right? So from this equation, from the first part of this equation, we can take common as x square, and by doing so we have what, x square into 1 minus y into dy, and plus, and from the second part of this equation, so we you can take common what, y square. By doing so, what do you have? So y square into 1 plus x into dx equal to 0. Okay, so now, so dividing both side, now dividing both side of this equation, so by, so x square into y square, so what do we have? We have, so we get, or we have, so what, 1 minus y divided by, so y square into dy, and so on dividing x square and y square on the second part of this equation, what we have, so y square will be cancelled out, and after that what we will have, so 1 plus x into dx divided by, so x square. And on further simplifying, so what do we have from this equation? So on further simplifying, so that is dividing y square and x square on this equation. So on the first part, dividing by y square, what do we have? So 1 by y square minus, so 1 y will be cancelled out, so then what we will have, 1 minus y, 1 by y into dy. And the second part of this equation, on dividing x square, what do we have? So 1 by x square, so plus 1 by x into dx. Okay, now on further simplifying, so what do we have? So 1 by y square dy minus 1 by y into dy, so plus 1 by x square into dx plus 1 by x into dx equal to 0. Now we are going to integrate, so both side. Okay, so on integrating, so what do we have? So on integrating, so integration 1 by y square into dy, so minus integration 1 by y into dy, so plus integration 1 by x square into dx, so plus 1 by x into dx integration equal to 0. So now we are going to solve all this integration on the left hand side, again on the right hand side. So what we will have? So integration 1 by y square into dy will be equal to y to the power minus 2 plus 1 divided by minus 2 plus 1, and the integration 1 by y dy will be, so by using the formula for integration 1 by x into dx, that is log of x, so we have what, log of y, so plus, so the value of this integration will be again x to the power minus 2 plus 1 divided by minus 2 plus 1, so plus, so the value of this integration will be log x equal to, so a integrating constant. Okay, so now on further simplifying, if we simplify further, then what do we have? So this value will be equal to minus 1 by y okay, then minus log y, and the value of this term will be equal to minus 1 by x, then plus log of x, so which is equal to a constant. Okay, so again for the simplifying, this the terms on the left hand side of this equation. So what do we have? So by using a formula of logarithm, that is log of a by b equal to, so log a minus log b. So we have what? So if we combine these two terms, so from this equation we have, so log x by y, so minus 1 by x minus 1 by y equal to c. So this is the required solution for a given differential equation. So now let us solve the second question, so which is again related to differential equation. And in this problem we have given a differential equation, this, that is x plus 3y cube into dy by dx equal to y. So now to solve this differential equation, if you are familiar with linear differential equation, then you are capable of solving this equation within a short time. So before going to solve this problem, so let us recall what is linear differential equation. There are two types of linear differential equation. I hope so all students are familiar with this two type of linear differential equation. The type 1 is what? So just observe these two structure, that is these two type of linear differential equation, and the solution associated with these two types of linear differential equation, then you are automatically able to solve this given differential equation. Okay, so type 1 is what? Dy by dx, so plus py equal to q. Okay, so here the solution for this differential equation was what? Y into integrating factor equal to integration, so q into integrating factor into dx plus integrating constant. Okay, so in this particular type of for this particular type of differential equation, linear differential equation, so the integrating factor is what? E to the power integration p into dx. Okay, so by following this structure and the solution associated with this linear differential equation, we can solve a given linear differential equation. Okay, so next type of linear differential equation to what? So next type of linear differential equation is what? So type 2 is what? So dx by dy, so plus p x equal to q. So in this case the required solution is x into integrating factor equal to integration, so q into integrating factor into dy plus c. So where integrating factor is what? So for this particular type of linear differential equation, the associated integrating factor is what? E to the power integration p into so dy. Okay, so by following this structure, that means by following the structure of this particular linear differential equation and the solution associated with this linear differential equation and the integrating factor associated with this linear differential equation, we are going to solve this question. Okay, so basically, so we have given what? This equation, x plus 3y cube into dy by dx equal to y. So now we are going to convert this equation to one of the type of linear differential equation which we have already discussed. There are two types of linear differential equation. You have already discussed. We have already learned this type of linear equation in your um, classes. Okay, so by converting this equation to one of the type of linear differential equation, we are going to solve this. So for converting this equation, so we are going to take some simplifications. Okay, so through these simplifications we can convert this equation to one of the type of linear differential equation. Okay, so now we are going to shift this term to the right hand side. So by doing so, what do we have? So x into 3y cube equal to y into dx by dy. Again, now we are going to shift y to the left hand side, and by doing so, so what do we have? We are going basically we are going to divide y both sides. By doing so, what do we have? So x by y plus 3y square equal to dx by dy. Okay, so why we are doing this kind of stuff here? So because we perform this kind of stuff here because we need to convert this equation to one of the type of particular linear differential equation. Okay, so now again, on further simplifying this equation, what we have? Dx by dy equal to minus x by y equal to 3y square. Now if you compare this equation to one of the type of linear differential equation, you can clearly verify that this equation is identical with type 2. Okay, so since this equation is identical with type 2, by comparing, so you can clearly observe that here, so p is what? So here p is so minus 1 by y, and q is what? 3y square. Okay, so for this type of linear differential equation, you know that, so the integrating factor is what? The integrating factor is calculated in this way, in the e to the power integration p into dy. Here p is what? Minus 1 by y. So by putting the value of p, so here, so we have e to the power integration minus 1 by y into dy. So, and from here what you will have? So e to the power minus, so log a log y, since integration of 1 by x into dx is equal to log x. So from here what you will have? So by removing the negative sign, what you will have? So in e to the power log, so 1 by 1. So by applying the property of log, so if you want to remove this negative sign, you just you just need to take the reciprocal of this term. Here the term is given as what? Y. So by taking reciprocal, uh, you just get what? You just get the negative sign will be vanished. Okay, so now, so from here, so what you will have? So the value of this term is equal to 1 by y. So now you have get what? So integrating factor is 1 by y. Now the solution for this particular differential equation is what? X into integrating factor. So for this particular differential equation, integrating factor is 1 by y. So equal to integration q into integrating factor. Here q is what? 3y square into integrating factor is what? 1 by y into dy. So plus integrating constant. So from here what you will have? X by y equal to, so integration 3y into dy plus c. Then further on simplifying, what you will have? So 3y into dy. So on integrating, what you will have? So 3y square divided by 2 plus c. Now on further simplifying, so what you will have? X is equal to 3y cube divided by 2 plus c into y. This is the required solution for a given differential equation. Okay, so in this way you can solve this.